All right. Good afternoon, everyone, and welcome to MOS Live. You're here for our virtual planetarium, the Sky Tonight program. My name is Becca. My pronouns are she and her. And today I'm very excited to be your moderator. What that means is I'm going to be sharing all of your observations and questions with our educator. If you're joining us on Zoom and would like to submit any questions, you can click on the Q&A box and type in your questions or answers to our educators' questions at any point during the program. If you are joining us on Zoom and would like closed captions, you can click on the CC button and hit show subtitles. And if you're joining us on Facebook or YouTube, we're very excited that you are watching along today, but please note that we won't be able to see any of your questions or comments live during the broadcast. So with that, I think it's time that we have our educator introduce themselves and get started.
Awesome. Thank you, Becca. Hi, everybody. My name is Katie. My pronouns are she and her. And today I'm going to be your educator as we tour around the nighttime sky. Now, what's super exciting about tomorrow is that it is officially the first day of spring. So if you live in a cold mid-northern latitude area similar to where I am, you might be very excited about that if you prefer the warmer weather. So I thought for today's program, we would start by just taking a look at what causes seasons a little bit for a few minutes, and then we'll transition over to looking at constellations that are really prominent in the sky that indicate the start of the springtime that will eventually get higher and higher up in the sky as we kind of move through the spring and into the summer. So to start, I'm going to bring us over to a program called Worldwide Telescope first. So most of this program is going to be done using Stellarium as usual, but for just this kind of first portion, I'm going to be using Worldwide Telescope just to talk about the seasons. This program is also free to download, open source. If you have a PC, unfortunately, it only runs on Windows, not Macs, but you can download it at worldwidetelescope.org/download if you're interested. So I thought we'd start here so that you can take a look at what is actually causing the seasons and what it looks like from space. So to start us off today, I'm going to just throw out a question. So what causes the seasons? What is it about the Earth itself that causes us to experience seasons over the course of a year? So you can type your answers into the Q&A. If you're not sure, you can just put a question mark or say, I don't know, because that's totally acceptable in science as well.
All right, so it looks like people are thinking about it, and we have an answer for the Earth rotates at an axis. We have question marks, and we have Earth's tilt is on an axis.
Yeah, that's correct. It is the tilt of the Earth. So Earth is tilted by about 23.5 degrees. And so in its orbit around the sun, sometimes it's tilted toward the sun, or the northern hemisphere is tilted toward the sun. Sometimes it's tilted away, and sometimes it's kind of in between there. And that is what causes the seasons. A lot of the times, a common misconception is that it's the distance away from the sun that the Earth is that causes the seasons. But Earth's orbit is relatively circular. It's almost a perfect circle. So there's really not a huge change in distances from the sun over the course of a year. And even if there was, the Earth is actually closest to the sun during the winter time. So even if that were the case, it wouldn't quite match up perfectly. So it is because of the Earth's tilt. So if we change our observing time, let's change it to this past December. And we're getting a view from the perspective of the sun. So if I turn around here, there's the sun. I've blown it up so that it's nice and big so you can see it. And if we look at the Earth, we're seeing mostly southern hemisphere continents, right? We're seeing a lot of Antarctica down there. We can see South America really well. And if we speed up time here, you can see Australia, and it's a lot harder to see the continents up in the northern hemisphere. And that's because during the winter, the northern winter solstice, or we can just say the December solstice, the northern hemisphere is tilted away from the sun. And so the sun isn't actually in the sky for as long as it would be other times of the year. So we're not getting as much heat, not as much direct sunlight, and so temperatures are colder for that reason. And if we fast forward time and go to June, or the June solstice, and we look once again from the perspective of the sun, we can see as we fast forward time, you're getting a much clearer view of the continents up in the northern hemisphere. You can see Greenland there, and there's some of the North Pole. You can see North America. So this is when the northern hemisphere is tilted toward the sun. So that's when we experience summertime up here. And the opposite is always true for the southern hemisphere. So while we're experiencing summertime up here in the north, they are experiencing wintertime. So the equinoxes fall on the dates that are in between, where it's not really tilted toward or away from the sun. Both hemispheres are equal. So let's go back to that date really quick. Let's see, I went the wrong way. There we go. So now when we look at it, you can see pretty much an equal amount of both hemispheres. So while we are entering the spring, the southern hemisphere is entering into the fall. And to help you visualize this a little bit better, I can show you a couple of graphics here. So you can see that red line is representing New England's latitude there. And so you can see the part of the red line that is in the sunlight during the winter solstice is shorter than the part of the red line that's in the dark. And the opposite is true for the summer solstice. So we got a lot more time in the sunlight. So I hope that clears it up just a little bit. But I think now we can head on into another program called Stellarium. So this is what I usually use for this sky tonight so that we can take a tour of what is visible in the nighttime sky. And we're going to be looking over mostly kind of in the northeast, eastern part of the sky. So we get all those constellations that are just rising during this time of the year. And it's important to note that the reason we have seasonal constellations, the reason why we can only see some constellations during some parts of the year has to do with where the Earth is in its orbit around the sun. So when we're on one side of the orbit, the nighttime side of the Earth is facing a completely different part of space. And I have actually another graphic for you. So this is mostly about seasons, but if you look over on the left side, summer in the northern hemisphere, winter in the southern hemisphere. If you look at the nighttime side of the Earth, it's facing a totally different part of space than if you were looking at the nighttime side of the Earth over in the opposite season. So if it was winter in the northern hemisphere, it's facing completely different parts of space. So that is why you see different constellations. There are some constellations you can see year round, and you can kind of think of those as being the ones that are directly above us. So it doesn't really matter which side of the sun we're on. They're always visible because they are above. Or if you're in the southern hemisphere, they're below. All right, let's go back to Stellarium, and I'm going to pause there and just see if any questions have come in so far.
There have not been any questions yet.
Okay, no worries. If you do have any questions throughout the program, please feel free to throw them into the chat. So the springtime in astronomy is, we see in a lot of the mythology behind the constellations that it's this time of growth and rebirth and planting crops and things like that, and mythologies across, various cultures. And we also see it as a really big time for festivals and celebrations because it's this transition between being in the dark for a very long period of time, the dark, cold weather, and transitioning into much warmer, happier feeling weather, with a lot of just plants and growth. It's the time of blossoming. And so there's a lot of celebrations, and this is evident throughout human history. There's a lot of evidence of ancient festivals and things like that. And so I did want to point out one really cool structure, I guess you would say, that is evident of this. And this is over in, here we go, the Yucatan Peninsula. So this is a pyramid that was built by the ancient Maya people back in the 8th century to 12th century AD. And it turns out that during the spring equinox, as well as the autumn equinox, the sun hits it in just the right way that actually creates what looks like a serpent. So I wanted to point this out because it looks pretty cool. So this is what it would look like on the spring equinox. And so it's kind of like a feathered serpent god from mythology of the Maya people. So this is just one example of some of the really awesome structures that have been built around the seasons. You know, pyramid, Stonehenge, they're all kind of related to the seasons and the changing seasons. So I just wanted to point that out. All right. So if we start in the northeastern part of the sky, we can find a very familiar group of stars. And if you've joined us before, I usually start with. It is a group of 7 stars that are roughly equal in brightness, except for maybe one of them. But if you're looking right up here at this group of stars, that is what I'm talking about. And it is the Big Dipper. Now, the Big Dipper is just a part of a constellation called Ursa Major, which is a great bear. And I can add the artwork to show you the bear. It's got a very long, fluffy tail, which is kind of weird. But I really like pointing out this constellation first because you can use the Big Dipper to find some other ones. And so that's exactly what we're going to do. We're going to take these 2 end stars of the Big Dipper here and, and we're going to connect them together. And instead of going in this direction, like we would to find the North Star and the Little Dipper, we're actually going to go in the opposite direction. And we're going to look for a group of stars that kind of looks like a question mark. So we can come down this way and it'll take us to the right area of the sky. And you can find these stars here that kind of look like a backwards question mark. And if I click on one of those, I'm going to take the artwork down so that you can guess what it is supposed to be. So if I click there, then we've got this constellation. So if you want to take any guesses of what you might think it is, or maybe you just want to type in what it looks like to you, please feel free to put that into the Q&A.
All right, and while we are maybe getting some guesses, I wonder if I can just ask a quick question.
Absolutely.
So we have a student who kind of wants to know what are constellations, but why can't we normally see them in the night sky? Like right now we can see all these lines, but why can't we see them normally?
Yeah, so constellations are all made up by people, right? They looked up at the nighttime sky and tried to kind of make some sense of it, tried to map it out. And so the constellation lines and figures and artwork and things like that is ultimately a way to map the sky and to remember where things are. And back in ancient times, and maybe sometimes now as well, people used the constellations to represent a lot of deities in many circumstances, or to tell stories of, other people. The Greek and Roman constellations, which are the ones that I've shown you so far, tend to be the ones that we might be most familiar with because they're the official constellations that are recognized. But really it's just to map the sky. And so when astronomers are using telescopes to observe objects really, really far away in our galaxy, they can say, this exoplanet is over in the direction of Canis Major. And so you kind of get a general sense of where in the sky you're looking. So it's basically just a map. And with really cool stories and really fun creatures involved too, which make it more exciting.
Awesome. Thanks, Katie. So we do have some people thinking that in the middle there, that constellation right in the center, could be Leo, the lion. We have quite a few people thinking that. People are thinking maybe it's a mouse or a duck or a swan or a horse. We're getting some good guesses.
Yeah, lots of animals, which is definitely on the right track. And for the folks who said Leo the lion, that is what it is in the Greek and Roman constellations. So the mane of the lion is kind of the top of the question mark here, and then it's kind of sitting down. And so this is the rest of its body. But if you said mouse or even like a coat hanger or something like that, I can totally see that as well. That is what's pretty awesome about the constellations, is that you can also make up your own. Because if it helps you find stuff in the sky, or you just want to create a new fun story, there's plenty of opportunities for that. So the reason I'm pointing out this constellation in particular is because it's a pretty big indicator of the spring. Once you start seeing Leo popping up low in the eastern sky, you know you're headed toward warmer weather. And so right now this is set to be viewing from around Boston. This is similar for all mid-northern latitudes around the world. And it's also set for 10 p.m. tonight. So this is where Leo would be in the sky at 10 p.m. tonight. If you were to go outside at like 8 o'clock, it'll still kind of be in this general area, just a little bit lower in the sky. So Leo the lion, a very prominent spring constellation. And we also see this in some other cultures as well. So I'm going to switch over to, let's see, where is it? Yes, the Ojibwe. This is a Native American group. Oh, this is really cool artwork. I never actually looked at the artwork for this one before.
That's awesome.
Yeah, it's very cool and colorful. So if I put the labels up here, and I'm going to take this down just for a moment. So you can see that part of what is normally Leo the lion is also part of this constellation, the Great Panther and the Curly Tail. And there is a story about why this constellation represents the springtime. So the Ojibwe people are a group of indigenous people that live in generally like the kind of central southern Canadian region, as well as the northern United States. And some of the stories that go behind this particular constellation is that there's this spirit cat that kind of lives at the bottom of a lake, and it also has the ability to cause flooding. So whenever this constellation is high up in the sky, it's said that the people then know that the ice is starting to melt, so that winter is over and flooding might start to happen. But it's also a period of regrowth and for planting and celebration and things like that as well. So I thought that this was a really cool kind of indicator for the spring. It had a good springtime theme to it. There are also some other constellations that have a springtime theme, like right over here, the Sweat Lodge. That's another indicator of the spring, of like purification and, you know, starting over. And this is all in the stories and the cultural mythologies behind it. Also, really just a cool feature of Stellarium. You can look at all different constellations from all different cultures all around the world. So I've learned a lot from just being able to play around with that.
That's so cool.
Yeah. So that's a couple, but there are more, and not all of them are populated. A lot of these particular constellations from the Ojibwe people, a lot of the stories and knowledge around it has been lost over time. And so there are people out there who are committed to restoring these stories and passing them down so that they're never forgotten. And so it's really nice that Stellarium is able to keep some of them, but hopefully we learn more and more about them so we can populate more of the sky, because you'll notice there are lots of blank spots here. All right, so I'm going to switch us back for a moment to talk about another constellation that is one of my favorites. Let's see, I'm going to take down the lines, and I'm going to show you how to find it first with the Big Dipper, and then I'll put the lines back up. But if you follow the handle of the Big Dipper here, and you kind of follow the arc that it makes, you can arc to a star low in the east here called Arcturus, which is very conveniently named. And that is part of a constellation called Bootes. And Bootes is another classic springtime constellation. I couldn't find too many stories about that are related to the spring about this particular constellation. But I really like it just because of this star. So the star itself is a red giant star. So, which basically just means that it's really, really, really big. But it's similar to our sun in one way. It's got the same mass as our sun. So mass is a measurement of how much stuff something is made up of, and size is how much space something takes up. So this star is made up of the same amount of stuff as the sun, but it's stretched out over a much bigger volume. So it's kind of like a fluffier star. You can kind of think of it like that. And so this star is very red. You can actually see it as looking red from this program here. It doesn't actually appear too red, but in the real nighttime sky, you might be able to spot that little reddish hue. And the reason that it is so big compared to our sun is that it's actually just further along in its lifetime. So as an average star approaches the end of its life, it gets a lot bigger. So our sun is in about the middle part of its life, and it's a very average star. So we've got another 4 to 5 billion years before the sun starts to get bigger. But Arcturus is kind of nearing that time. And when an average star starts to run out of fuel and get big like that, eventually it will just shed its outer layers of gas. So this is an animation of what happens when an average star starts to run out of fuel. So as we come up on this very colorful looking cloud, this is called a nebula, specifically a planetary nebula. We can start to see all of those outer layers of the star that have been shed away out into space. And just remaining is the core of the star that is left over, just the central part. That will eventually cool down. And all of this material, I thought it kind of fit into the whole spring theme really well, because everything in space is recycled, right? When stars die and they shed their outer layers, or if it's a really massive star, if it explodes, that material eventually travels through space and might form new stars or condense into planets. So this material is always kind of being used, recycled, and being turned into something new in the universe. All right. So, Becca, have there been any other questions that have come in so far?
There have been quite a few. A few people are actually wondering, how many constellations are there?
That is a good question. So, of the official International Astronomical Union constellations, there are 88 of them. And you can't see them all at one time because it depends on what time of the year it is. And it also depends where you are on Earth. So if you're in the southern hemisphere, you will see some different constellations than you would up here in the north. So at any given time, you'll see about 22. But that's just the official constellations. There are so many from a whole bunch of other cultures out there. So if we look at the Chinese constellations, you can see they have a lot of really small constellations. So there's a million of them. So many. So the actual number, I couldn't tell you. It's a lot.
That's so cool. So you kind of also were able to answer this question, but maybe we could talk about a couple specifically. But there's a question about, are there constellations in the southern hemisphere that we can't see in the northern hemisphere?
Yeah, there are quite a bit. So if we look at the dippers, the Big Dipper and the Little Dipper, those are circumpolar groups of stars, which means that we can see them all year round because they're so far north. They're close to the North Pole. If you were to kind of line up, where that would be in the sky, that people in the southern hemisphere will never be able to see these constellations. And so equally, in the southern hemisphere, there are constellations that we would never be able to see. And we can actually, let's take a little trip real quick and let's go visit, let's see, let's go to Santiago comes to mind first.
That's what I was just thinking. That's where I saw really cool constellations.
Oh, that's awesome. Yeah, I've heard that the constellations in the southern hemisphere, because there's in a lot of places that it's very dry, like up in the Andes, you can see so much more. And the Milky Way is incredibly bright and everything, which is awesome. All right, so if we look over kind of in the southern part of the sky, this is where you're going to see a lot of constellations that we will never be able to see up here in the northern hemisphere. And I will admit I'm very bad when it comes to my southern hemisphere constellations, but I can tell you right over here, this one, this is called the Southern Cross, and it's kind of like the North Star up here in the northern hemisphere, where we use the North Star and Ursa Minor to find north, because it happens to line up with Earth's northern axis. Well, this constellation doesn't quite line up perfectly with the southern axis, but it's very close. So when you find the Southern Cross, you can easily find where south is in the southern hemisphere.
Very cool. And we have a question here. When stars like Arcturus start to explode and shed, does that make noise?
That is a very good question. So a star like Arcturus is actually not big enough to explode. So this kind of shedding process happens over a very long period of time. Does it make a sound? I imagine that while all stars make sounds, if there's something for sound to travel through, right? Like out in space, space is a vacuum. So there's nothing, there's no air, there's nothing for sound waves to actually travel through. So technically everything in space is quiet. Even a really massive explosion, unless there is something for the sound to travel through, it won't like actually make a noise. But there are waves that propagate from a star exploding. That's how the material kind of gets thrown out into space. So there is kind of some element of energy propagation and expulsion outward, but I don't necessarily know that you'd be able to hear it itself. That's an interesting question.
All right, and I think we have time for maybe just one more question before we have to end. And we have a question here about, with all of these stars, why is it dark at night?
Yeah, another good question. So the idea there, I forget the name of it. There is a paradox named because of this phenomenon. So if the universe is infinitely large and there are stars all over the place, why isn't the nighttime sky just completely blindingly light? Well, it's because the farther you get, the more light that kind of gets scattered away on its journey. So a star that might be, several million light years away, it has to travel millions of light years through space to reach our eyeballs. And in that process, light gets absorbed by dust and gas that's in the area. It could get bent a little bit because of an object that's got really strong gravity. And so you end up losing a lot of the light once it finally hits your eyes. That's just a fraction of the light that left that object initially. So even though there's stars in every single part of the sky, even stars that you can't see, it's because the farther things away are, the harder it is to see all of its light, if that makes sense.
Awesome. Well, thank you so much, Katie. I know we are just about out of time, even though we have a few more questions, but I'd like to give you your opportunity to say goodbye as well.
Bye, everyone. Thanks so much for joining. Great questions, great observations. I hope you'll join again soon. Thanks.
Thanks, Katie. And thank you, everyone, for joining us today. I hope that you enjoyed learning a little bit about the sky tonight and the spring sky. We'll definitely have a few more of these, so check out www.mos.org/MOS at home for a full list of our virtual offerings. And if you enjoyed this program and are willing and able to support the museum, you can head to engage.mos.org/welcome. And this program was produced using Stellarium, which you can go and download and play around with yourself and look at all of the different constellations out there by going to www.stellarium.org. Bye, everyone. Thanks for joining us today.